Hey everyone, in this video we will be going over solving stoichiometry problems. You can see that this is in a little bit different format than normal. We're in a Word document instead of a PowerPoint, but we're just going to go through the 3 steps to solving any stoichiometry problem and do 3 examples. We're going to use the steps listed up here as well as this lovely map in the middle of the page. So, stoichiometry is just using your chemical reaction, your balanced chemical reaction, to look at the ratios of the different substances. We can use those ratios to ultimately predict, how much product we're going to make or how much of our other reactant we will need. Stoichiometry is great for a practical look at chemistry. If we think about, chemical reactions making usable chemicals like medications or plastics or things of that nature, we then also can think about, okay, well, certain ingredients cost a certain amount of money. I want to make sure I have the appropriate amount of each of those ingredients so I'm not being wasteful. I also want to make sure that I'm maximizing the amount of product I can make. So from a practical standpoint, stoichiometry is the root of chemistry. So let's go through the 3 steps that you will go through in order to solve any stoichiometry problem. So step number 1 is always to convert your given value to moles. So remember that your ratio from the equation is really a mole ratio. So before we can use that mole ratio, we have to get our given value in moles. And unfortunately, in most situations, we don't have a machine that measures the amount of moles, but we do have tools to measure the mass in grams, the volume in liters, or maybe we know the particles, but I'm not really as worried about that one. Okay, so of our given known substance, step 1 is going to be to convert it to moles. You can see on the map here, all the arrows are pointing in one direction toward moles. We are dividing for each of these. This is a division sign. Dividing by molar mass, dividing by 22.4, or in rare cases, dividing by 6.02 times 10 to the 23rd. Okay, once you have your value, your given value in moles, then you use the mole to mole ratio that comes from the coefficients from the balanced chemical equation. So we're going to use the mole to mole ratio. All of this is going to be using dimensional analysis, so we will set it up in a way to make sure that our units cancel appropriately. This is the transition from our given known substance to the unknown substance that we're asked about. The mole to mole ratio is what allows us to translate from substance A to substance B. As you can see, the colors also change on this map. Okay, then after we do that, okay, that's step 2. Step 3 is going from moles to desired units. So we have to look at the problem and say, what did the problem actually ask me for? Did it ask me for grams? Did it ask me for liters? Did it for some reason ask me for particles? We don't know, but either way, we will be multiplying by that conversion factor to get us from moles to the desired units. Okay, that is the maximum number of steps. The maximum number of steps is 3. Okay, 3 steps is your maximum. If you're given a value in moles, then step 1's already done for you, right? You would be then starting right here. If you're only asked for moles, then you're done after step 2 because your desired unit would be moles. So it's a maximum of 3 steps, but you may not do all 3 steps depending on what the given value is and its units are and what your desired units are. So let's do some examples. We will follow these 3 steps. I might even do them in different colors. Maybe not though. All right. So the first example, we're going to use the same equation up here for all 3 of our examples. Also be considering, refreshing your memory. What type of reaction is this, etc. So our question is, how many liters of H2 gas will be produced at STP by the reaction of 10.0 grams of Mg? And then we have this weird part of the question with excess HCl in the reaction above. All right, so let's kind of break that down. I do see a given value here, right? My given value is 10.0 grams of Mg. So I'm going to put that on a dimensional analysis track and count that as my given. Okay, this extra part at the end here, the excess HCl, all that means is that I have plenty of HCl. I'm not worried about how much HCl I have. Excess really means like extra, right? So I'm not really worried about that. I'm kind of just going to cross it out. That just means I have plenty of it and don't worry about it. And then I'm going to go and look at the question word and see what comes after that to figure out what I'm actually solving for. So it says how many liters of H2. Okay, and then it does tell us at STP, which does allow us to use the 22.4 number that we have learned about. So starting with 10.0 grams of Mg, magnesium, and going to liters of H2. So if I look at the map here, I am given 10 grams of magnesium, so I'm starting up here in grams. I need to get to moles, use the mole to mole ratio, and then get to liters. So this is going to be my path. So we're going to set that up in a long dimensional analysis, and you're going to see how the units will cancel. So step one is to get grams to moles. So in order to do that, I need to divide by the molar mass. The molar mass, remember, comes from the periodic table. So I'm going to find magnesium on the periodic table, and it has a mass of 24.31 grams of Mg, and that is equivalent to 1 mole of Mg. Remember, every conversion factor on a dimensional analysis problem is a ratio, right? So 24.31 grams of magnesium per every 1 mole. I set it up that way so grams and grams cancel. So step one is done. Moving to step two, I now am going to use the mole to mole ratio. Magnesium is here, H2 is here. So 1 mole of magnesium is going to go on the bottom, and 1 mole of H2 is going to go on the top. Where did those numbers come from? Well, when there's no number out in front of a substance in a chemical equation, we assume that that's a 1, right? Chemists are lazy. We don't need to write a 1 there. Just by writing the formula tells us we have one of them. We'll only indicate if we have more than one. So 1 magnesium, for every 1 magnesium atom I put in, I'm going to get 1 molecule of H2. Or for every 1 mole of magnesium I put in, I'm going to get 1 mole of H2 produced. I set this up. It's a 1-to-1 ratio. It is still important to include it, okay? And I set it up in a way so that moles of Mg cancel with moles of Mg. So that's step two. That's the mole to mole ratio there. Now I'm going to convert to desired units. So notice it says to multiply up here by 22.4. Well, if I follow my units, I'm going to put 1 mole of H2 on the bottom, and that's equivalent to 22.4 liters of H2 when we're at STP. I set it up that way so that moles of H2 cancel moles of H2. So when I do my dimensional analysis math, I can multiply everything on the top, multiply everything on the bottom, and then divide, or however you're used to solving these problems. I'm going to have 3 sig figs in my answer to match the 3 sig figs in my given, and I should get 9.21 liters of H2. That is my final answer for example 1. So again, I took the 10 grams of magnesium as my given. I converted that to moles, step 1. Step 2, I multiplied by the moles-to-mole ratio. In this case, it happened to be a 1-to-1 ratio. Nice and simple. And then the last step, converting moles to the desired units. In this case, the question asked for liters. So I converted to liters by multiplying by 22.4 liters because that is the ratio of liters to moles at STP. Did the math, got an answer of 9.21 liters of H2. Notice how in my problem and in my work, I kept the units and the substances. Without the substances, those units don't really have much meaning, so it's important to keep both. And I promise it will help you as you work through the problems. So let's try another example. What mass of MgCl2 will be produced by the reaction of 15.0 grams of HCl with excess Mg? So again, we see that with excess. That just means I have extra, not worried about the Mg, the magnesium in this case, just worried about the 15 grams of HCl. So that's my given. Write that out. List my given value. Okay, then we'll think about where we're going. So we are going to mass of HCl, right? What mass of HCl? So that's, or excuse me, not HCl, MgCl2. So step one, given to moles. So in this case, I again am in grams. I need to get down to moles, so I need to divide by the molar mass. So I'm going to divide by the molar mass. Grams of HCl go on the bottom, 1 mole of HCl on the top. Molar mass is just the ratio of grams to moles. I add hydrogen plus chlorine and get a molar mass of 36.46. Remember, molar mass comes from the periodic table. Okay, so grams of HCl canceled. Step 2, now I'm going to convert from HCl to that other substance I'm asked about using the ratio from the equation. So I'm going to put moles of HCl on the bottom and moles of MgCl2 on the top. Now I'm going to pull the ratio from the balanced equation. What this says is that 2 moles of HCl will produce just 1 mole of MgCl2. It's a 2-to-1 ratio, but I have to plug it in so that moles of HCl will cancel. That's why this dimensional analysis setup is so beneficial, because you can actually track your units and make sure that you're multiplying by the appropriate ratio. All right, so I converted my grams to moles. Now I converted moles of HCl to moles of MgCl2, and now I'm going to complete step 3 of going to the desired units. Whatever unit I have on top has to go on the bottom. So moles of MgCl2 goes on the bottom, and I'm going to put the molar mass of MgCl2 on the top because I'm asked for the mass. So if I look up at my map here, okay, I started over here. I'm trying to get over here. So divide by molar mass, mole-to-mole ratio, and then I'm going to multiply by molar mass. You can almost see a little bit of symmetry as we're working through this. So now I'm going to add Mg plus 2 Cl's from the periodic table. That molar mass is 95.21 grams. Moles of MgCl2 cancel. And again, I should have 3 significant figures in my answer, and I'm going to get 19.6 grams of MgCl2. So if I kind of break this down, the calculation we just did was we said, okay, I have 15 grams of, this ingredient, HCl. How much product can I make? That's an important question. If you're working in a lab, again, where you're producing a substance, you need to know how much ingredient, you put that in, how much product do you actually have the potential to make? Those are important questions that have to be answered when different products and medications and things of that nature are being made. All right, I would encourage you at this point to pause the video to try the third example on your own. I will go over it in just a moment. Okay, so I'm going to go ahead and write it all out and go over it, but hopefully you are just checking your work at this point. This problem says if 3.2 grams of H2 is produced, what mass of magnesium did you have to start with? This is a little bit different, right? This time I'm starting, my given value is actually a product. It's on the right side of the equation, and I'm asked for a reactant. That's totally fine. These ratios are interchangeable. You can compare any two substances in the equation, same side, opposite side, starting with reactants, ending with products, starting with products, ending with reactants. Okay, this is also a practical question if we think about it, because if we think and say, okay, I have to make this much product, how much ingredient or reactant do I have to put in to do that, right? How much ingredient do I have to buy to make the desired amount of product? That's a valid question. So 3.2 grams of H2 is my given value. Mass of Mg is where I'm going. So 3.2 grams of H2 is my given value. Step 1, given to moles. So I need to divide by the molar mass of H2. 2.02 comes from the periodic table, is how many grams are in 1 mole of H2. Grams of H2 are now canceled. Now I'm going to use the mole-to-mole ratio going from H2 to the desired substance of Mg. Moles of H2 goes on the bottom. Moles of Mg goes on the top. And I pull their coefficients from the equation. The invisible coefficient on magnesium is a 1. The invisible coefficient on the H2 is also a 1. So again, these are a 1-to-1 ratio. Moles of H2 cancel. And then the last step, convert moles of substance B to the desired units of substance B. In this case, I'm asked for mass, so the desired units would be grams. 1 mole of Mg on the bottom, molar mass of magnesium on the top, which is 2.31. And moles of magnesium cancel. I do the math here, multiply everything on the top, multiply everything on the bottom, do your division, 3 sig figs in your answer, 38.5 grams of magnesium. You can almost see the symmetry, right? Divide, ratio, multiply. Divide, ratio, multiply. Every time. Again, you may not have all 3 steps to do. If you're given values in moles, step 1 was already done for you. So you move on to step 2. If your desired unit is moles, then step 3 isn't necessary. Okay, so just think about these 3 steps are your maximum. You may not need all of them, but feel free to use this map for any of your problems, always using a balanced chemical equation for your mole-to-mole ratio.